Alright guys, now we're done the lecture part of stationary fire pumps. We're going to talk about your skill station. So first off, we're going to talk about the PPE needed. You guys are going to need a hard hat, safety glasses, ear protection, leather gloves, long pants, and safety toe boots. So we're going to go over the checklist. You guys have a copy in front of you. This is going to be the same checklist you use during the skills portion. So basically, this box right here says basic pump data. You're going to find most of that on the data plate of the pump. We talked about that in the lecture. So you're going to fill out everything in that box, including the pump ID number, what type of pump, which we learned, the rating, the driver, the different ways it starts, engine hours. The engine hours are important. Gives us a look into whether they're testing the pump. If it's running too often during the test, we can compare the numbers. The supply, any water demands on the pump. Alright, so if you go to the next page, we're going to take a look at the setup box. So basically the way this works is you go line by line, straight down. And if it doesn't apply, it's important that you just leave it blank. If you don't know, don't fill it in, because these forms are often used by the insurance company. They'll take a look at these and take a look at the report. So if it doesn't apply, you leave it blank. Basically, you're setting up your test gauges and opening them. You're verifying the proper location and elevations. The pressure relief valve has to be gagged so that you go over the 150 psi. Pump is isolated from the rest of the water system. And then you're checking the test header, make sure it's set up correctly, make sure the drain's closed. Pump's lined up to the test header, so it's not going into the system. The next box is going to be the visual inspection for the driver, pump, and controller. Again, if it doesn't apply, leave it blank. So you're looking for the shaft guards, make sure they're in place. Make sure the piping is in good condition. If it's a vertical pump, there's going to be suction screens. You want to make sure they're clear, that they're actually there. Sometimes they can rot away. Make sure there's nothing blocking them. If it's coming from, if the water supplies from a tank or reservoir, make sure it's full, it has enough water for the test. And again, just check and make sure all the piping looks good, nothing crazy, no holes in it, nothing's rotted out, everything looks safe. Of course, if it's okay, you check okay. If there's an issue, check C notes, and then you'll put a little number next to it. In your notes section, you'll put the same number down there, and you'll write what the issue is. That way you can go back and address it later with the property owner. The next part is a visual inspection of the test header. So there's going to be a test header. When you do your test, you close the valve to the rest of the system, you open the valve to the test header. So depending on the size of the pump, there's going to be a different number of outlets, discharges. It could be different sizes, 5-inch, 4-inch, 2-inch, 2.5. Depends on what they have. But you're going to check every discharge should have its own valve. So make sure the valve's in operating condition. You have to be able to open and close it all the way. Make sure the drain has to have a drain. So make sure that works and it actually drains. Check the isolation valve. Make sure that closes all the way, opens all the way. Check the piping condition. Make sure there's no leaks, no holes in it. It's not rotted out. You're going to check the supports. Make sure they're there. Make sure it's safe. And then all the discharges should have a cap. Protect debris from getting in there and that kind of thing. So make sure they're there. They have to be there. The next part is going to be a visual inspection of the enclosure. Pumps have to be protected from the elements. Sometimes they can be within the building itself. a bigger building, or sometimes it has its own little building. So you're checking the roof, make sure there's no holes, no leaks. You're checking the insulation, you're checking the doors and windows, the drainage, any heat tracing that there might be, the insulation, because you have to maintain a certain temperature so nothing freezes, breaks. And then the vent and louvers. They should have vent and louvers that are automatic, so that when the pump starts, they open, allowing fresh air in, and anything that might be bad out. Exhaust, any kind of fumes like that. Now we're going to get into the operational test observations. So, if it's a diesel, the first few lines apply to it. You're going to check the fuel system. Is there fuel in it? You're going to check the air system. You're going to check the exhaust system for any leaks. You're going to check the coolant system, all the valves, all the piping, the temperature, which when you do your test, that's one of the things to write down is the temperature of the engine. That's important because it can tell us if there's any kind of mechanical failure or something starting to go. It should be a normal operating temperature. Checking the lube system, the oil level, pressure, and the starting system. It should always have two different banks of batteries in case one fails. There'll be A bank and a B bank. Then you're going into, for electric motors, you're going to take voltage and charge reading. Make sure the voltage drop is good. You're going to check the controller. Make sure all the auto and remote starts work. You're going to check make sure there's no alarms on the controller. If it's a vertical turbine pump with a right angle, you're going to check the vibrations and any sounds that aren't supposed to be happening. When you're checking the right angle drive, it's not always a 1-to-1 ratio. Sometimes it can be 4 to 3 or 3 to 4. So you have to verify that, and if so, when you do your test, plotting your pump curve, you have to take that into account. And then you're checking the pressure regulated valve and the suction discharge valves to make sure they function properly. So let's get into the testing equipment. This is the stuff you're going to be using to do the test. There's all kinds of gauges, digital, analog. So it's important to make sure you're using the right gauge on the right side of the pump. You should know what side to suction and put a vacuum gauge on there. And for the discharge side, make sure you have a gauge sufficient for the highest discharge pressure of the pump. So you can't put a 100 max PSI gauge on a 300 PSI at the pump. And the other important part is the gauges have to be calibrated annually. If they're not calibrated within that last year, you can't use them for the test. So it's good to have a couple extras, a couple backups. If you use a gauge like this, it runs on batteries, so it's good to have a few extra with you. Let's talk about the different ways you can measure the flow, right? Because you're going to have to be able to measure flow to do the pump curve. The main ways are hose monitors, pitot tube, pitot-less nozzles, and a flow meter. So when we're talking about hose monitors, this is a picture of hose monitors. It's a big diffuser. So basically, here's a hydrant flow test. Diffuser, that's the hose monitor. There's a guy air hose hooked up to here. Well, not air hose, water hose to a gauge. It's going to give you a reading on that gauge, and then there's a chart, and the PSI reading converts to a flow measurement. So here's one hooked up to a test header. Because of the size of the pump, he needs 3 hose monitors. So he's got 3 hoses running to a manifold with 1 gauge on it, and he can take all 3 readings from that 1 manifold, and he's going to get these to where the number that he needs. And same thing, the PSI is going to convert to a flow. The next one is here's a picture of the chart. So you're flowing 45 PSI on one of those hose monitors, is 2,278 gallons per minute. So it's real simple to use. Another way is a pitot tube. This is kind of more old school nowadays. You don't see it used as often. If you know what you're doing, it's accurate. If you don't know what you're doing, it's not accurate. Basically, same concept, it's got a pressure gauge, converts to a flow. You have to get this piece into the center of the discharge to get the most accurate reading. It's not the easiest thing to do. You don't really see too many people doing that unless you're old school. What replaces this is called a pewterless nozzle. This is what you see a lot of. Same thing, PSI converts it to a flow. Here's a test header. I'm not a fan of this test header because look at the space they're working in. They're trying to get their measurements and they're trying to adjust the valves, and it's just a bad spot to be in. But it's the same concept. Takes the pressure, converts it to flow. So depending on what the pump size pump it is, depends on how many nozzles you use. Now we're talking about a flow meter. So some installations will have an inline flow meter. Usually a higher money owner will install a flow meter because they want to know what they're flowing. It's important. But the important part is if you're going to use a flow meter for an NFPA 20 annual fire pump test, it has to be calibrated within the last year. So if it's not calibrated within the last year, you can't use it. So you have to ensure that. So now we're going to get into a little bit of the skills. So now you guys kind of have an idea what you're going to have to do. You're going to have to hook up the pressure gauges, hook up the test header. One thing we forgot to talk about is to get the RPM. It's a timing light. So basically, the pump is rated to 1750 RPM. You preset the timing light to that speed, and when the pump's running, you'll see the rotating shaft right here. You turn that light on, and then you turn a dial until it looks like the shaft isn't moving anymore. That means it's at the same speed, the light's flashing at the same speed as the shaft. So that's how you're going to get your RPM reading. So that's how you do that. So you guys know how to set up the gauges, set up the test header. So the first point on the pump curve that you're going to do your test to is 0%, also called a churn. You're not pumping any water. So it's important to get these numbers quick because, as you all know, it's not good to dead at a pump. So you guys want to write down these numbers. This is going to be our test. So we're flowing 0, no gallons per minute. We got our light. Our RPMs are 1788, right? Now this is our discharge side of the pump. We got a pressure reading of 190, and then on the suction side, we have a pressure reading of 65. So you're going to write those in the boxes, and then obviously if you're working with a diesel engine like this is, you're going to do your temperature reading, and you're going to do your oil pressure reading. And while you're doing this, just keep an eye on the motor. Make sure nothing's about to fail. So now the next step is you move to 100%, the rated flow. This is where you'll have communication to the guy at the test header. And you'll say, okay, let's go to 100%. He should already have an idea. You already know what number you're shooting for on the hose monster because you know what the flow of the pump is. So the guy working the test header is going to be aiming for a specific number on the hose monster. So we know that we need to hit, I believe this pump's a 1950. So we're trying to get close to about 2,000 RPM. It doesn't have to be perfect as long as it's close. So he's going to be trying to get to 2,000 GPM. So here's our numbers for 100%. Our guy on the test header, he's got 2 hose monsters, each at 9 PSI. So that's our flow. RPM didn't change, still 1788. Our discharge pressure went to 137, and our suction pressure went to 38. So that's our next point on the curve. That's the rated point of the pump. Now, next point, our third point is going to be 150% of the rated capacity of the pump. That's to make sure that the pump's not falling off the curve to the right side. So you go beyond the rated point. So, our guy on the test header, he's getting 2 hose monsters at 15 psi each. So that's our flow number. Our RPM it went up 1789. Our discharge pressure is going to be 112, and the suction is 31. So you guys will be working, kind of as a team to do this. One guy on the test center, one guy running the pump, and you're going to be talking to each other to get these numbers. So that's it. That's the test. We talked about in the lecture how to gag a PR pressure relief valve. So for the skill's sake, that will already be done. You don't have to worry about that. You just have to know how to do it and identify what a pressure relief valve is. So now, if we go to our spreadsheet, this spreadsheet's going to be built for you already. You don't have to worry about building this spreadsheet. So this is our pump that we just did. Here's our manufactured test curve, right? It's rated at 1950 GPM. And then 150 is 25. And there's our just discharge pressures. These numbers here are from previous years. It's good to include previous years, which are also these 2 curves here. So you can see it's been trending above the minimum curve allowed by NFPA. It's good to have previous years curves on there because if a problem develops over time, you'll be able to see that through the pump curves. So now here is our different test points. We're going to have 3 test points. 0 is our churn. So right in this column is the nozzle code. So depending on what you're using on the test header, which for your skill is going to be a hose monster. So hose monster is HM. That's what you put there if you're using a hose monster. We're only going to be using a 4-inch hose monster. The coefficient or K factor, 339.65. You don't really need to know the importance of that. But basically, that goes into the formula that plots this curve. So here is where you're going to enter the pump speed, the RPMs. This is where discharge pressure goes, and this is where your suction pressure goes. Now, you can see there's a number in here already. It's going to give you a flow reading. So then it's going to automatically calculate the total flow. So that whole chart where it's got the PSI and the flow on one side, it's automatic. You put in the number here, it's going to give you the correct flow based on that chart. Everything's built into it. So it's real simple to do. So you get all your numbers for 0%, 100%, and 150%, you put it in here. So let's go to our churn numbers. What was our pump speed?
1788.
Yep, so you're going to enter 1788 here. What was our discharge pressure?
190.
190. And our suction?
65.
65. Alright, let's not worry about flow numbers right now. Let's stay with the RPM. What was our RPM for the 100%?
1788.
Yep. And what was our discharge?
137.
137. And what was our suction?
38.
38. Now let's take a look at the 150%. What was our RPMs?
1789.
1789. And our discharge?
112.
112. And our suction?
31.
31. Now, we had 2 hose monsters, right, for 100%. What was our 2 numbers on the hose monster, PSI?
9.
9, right? They're both 9. So we put a 9 right here on nozzle pressure. Alright, what was our numbers for the 150?
15.
15, right, for both of them? So we put the 15 here. Enter, plot your curve. So let me get rid of the 2 last years. You can see we're right on the same trend as the last 2 years' curves. Alright, so there's the curve we just did. Obviously, so the dotted red is the minimum allowed by NFPA standard. 10% of the rated curve. So obviously we're above it. So this would be a passing pump test. So when you go to do your skill station, important part, know which side is the suction of the pump, what side is the discharge. We talked about that in the lecture. Isolate the fire protection system and open the valve to the test header. Set up your test header equipment. Figure out what numbers on the hose monitors you need to hit the right GPM for the pump. Conduct the test. Put it into the spreadsheet, plot the curve, and tell me if it's a pass or fail. That's all you gotta do for the skills. Anybody got any questions? No? Alright, cool. Thank you guys.